ourselves to calculus part 1. For question 1, we need to use the principles of differentiation to find our derivative. And of course, we know the formula that we need to use if we're using first principles is and this formula is given in your formula sheet. Alright, so let's begin. And for the first part, where there's x, we're going to substitute x plus h. F of x we write as it is, all divided by h. The part inside the bracket, x plus h squared, will give us negative times negative is positive. Negative times negative again is positive. So we distribute minus 3 into the bracket. And of course, we've got some cancellations here. That term will cancel out with that term. Constants will cancel. So what we're left with is and of course we can divide both terms by h. So those h's will cancel, and this h will cancel one of those h's. So we're left with negative x minus 3h. And finally, we can take the limit as h approaches 0. So if that part becomes 0, so we can finally make h 0. And as you can see, we're left with negative 6x. That is our solution. Alright, for question 2, we're given a cubic function. And for 2.1, we need to find the roots of this function. And of course, in order to find the roots, we need to try out different values. We usually try 1 and then 2. And then minus 1 or 2 and negative 2. Those will usually work. And we substitute them into f of x, and they will give us. So if any of these substituted into f of x will give us 0, then we know that we've got a root, or that value is going to be one of the roots. Okay, so let's substitute 1 into f of x and see what we get. So starting with 1, 1 minus 1 is 0. And minus 8 plus 12 is 4. So 1 is not a root. Let's try 2. Let's substitute 2 into f of x. And of course, if 2 doesn't work, we'll try negative 1 and then negative 2. 2 cubed is 8. It's 4, 16 plus 12. And of course, 8 minus 4 is 4, and 4 plus 12 is 16, minus 16, 0. So definitely that is one of the roots. So 2 is one of the roots. So once we found one of the roots, we can then use the diagonal multiplication to find the other roots. Okay, so let's do that. Okay, so remember, we know that x equals to 2 is one of the roots, and we worked that out using substitution. Now we want to use the 2 to find the other roots, and the easiest method to do this would be to use diagonal multiplication. So the 2, which is one of the roots, we'll put on the left, and then on the right we put the coefficient of x. So the coefficient of x cubed is 1, and the coefficient of x squared is negative 1. The coefficient of x is negative 8, and we've got a constant of 12. And of course, you can also use polynomial division if that's the way your teacher taught you. Okay, so to start the process, we need to bring this one down, and then we can start diagonal multiplication, which 2 times 1 will give us 2, and we'll write it here. And of course, negative 1 plus 2 will give us 1. Diagonal multiplication again, 2 times 1 will give us 2, and then negative 8 plus 2 will give us negative 6. Diagonal multiplication again, 2 times negative 6 is negative 12, and that'll give us 0. Alright, so what we have here are the coefficients of the quadratic function. So the quadratic function will be x squared, the coefficient is 1, and the coefficient of x is also 1, and our constant is negative 6. Now, to find the roots, we can factorize. Alright, so we can factorize using positive 3 and negative 2 inside the bracket. And then, of course, this simplifies to x negative 3 and x equals to 2. Of course, we already knew this root. We already knew that 2 was one of the roots. So we've got one more root. So for this function, we have 2 roots. For 2.2, we need to find the stationary points. And the way we find the stationary points is that we make the first derivative equal to 0. And then we factorize. Alright, so if we take the first derivative, x cubed will be 3x squared. Negative x squared will be negative 2x. And that will be negative 8. This must equal to 0. And now we may use our quadratic formula to simplify. Of course, this is A, this is B, and that is C. So minus B plus or minus B squared minus 4A C all divided by 2a. Alright, so to simplify this further, negative times a negative is positive 2. Negative 4 squared is 4. Alright, negative 4 times 3 is negative 12. And of course, negative 12 times negative 8 is positive 96. You can check that with your calculator if you need to. Just pause the video. And of course, this will now simplify to so if you go to your calculator, we're going to start with a positive root. So we've got 2 plus square root of 100 divided by 6. So we've got x equals to 2. And now let's make the root negative. And this will give us okay. So finally, to find our turning point, we can substitute those roots into ff to get the y value. So to get the y value, we can substitute f of 2 into f of x. So let's do that quickly. So we start with 2. Okay, so that'll give us 0. And of course, we know that because that was one of the roots of 2 is one of the roots of the function. Okay, let's also substitute negative 4 over 3 into f of x. Okay, so if we substitute negative 4 over 3 into f of x, we get 500 over 27. So our stationary point will be, remember our stationary points are turning points of a cubic function, will be x is 2, y is 0. And the other stationary point will be, so that's stationary point 1, stationary point 2 will be negative 4 over 3. Okay, so we found our stationary points. Again, all you need to do is you need to factorize. And once you have your x value, substitute that x value into the original f of x to get the y value. And this is how you find your stationary points. Alright, so for 2.3, those stationary points that we have just determined in the previous question, now we need to classify them. So to classify the stationary points, we need to say which of those turning points is the minimum, which of those turning points is the maximum, local minima, local maximum. Alright, so how do we then classify the stationary points? First of all, we know that the stationary points from the previous question, one stationary point is 2 and 0, and the other stationary point is negative 4 over 3 and 500 over 27. So those are our stationary points from the previous question. Okay, so now we need to classify them. And how do you classify stationary points? You need to insert the x value of that stationary point into the second derivative. Now we know the first derivative of x is 3 over x squared minus 2x minus 8. We know that from the previous question. Now the second derivative of x will be 6x minus 2. And what we want to do in order to check our stationary points or to classify them, we want to insert our x values starting with 2 into the second derivative. So we insert 2 into the second derivative. This is of course 6 times 2 is 12 minus 2 is 10. And as you can see, 10 is positive. 10 is positive, smaller than 0. So what this tells us is that here the graph will be concave up. Remember, concave up means it's looking up. So if it's looking up, that means we've got our local minimum at that point. Okay. Let us also insert that x coordinate into the second derivative to be able to classify that point. Okay, so remember 6 divided by 3 is 2, and 2 multiplied by negative 4 is negative 8, and negative 8 minus 2 is negative 10. And this one is negative. It's less than 0, meaning that it's concave. The function is concave down at this point. So it's facing downwards. So that has to be the local maximum. Alright, so now we can classify our stationary points. We know that this stationary point is the local minimum, and this particular stationary point is the local maximum. Okay, that will be important when we sketch the graph. Alright, so for 2.4, we are looking for the point of inflection where the graph changes concavity. Alright, so to get the point of inflection, we need to take the second derivative and we must equate it to 0. And if we go to the previous question, we know that our second derivative is negative 6x minus 2. So our second derivative is 6x minus 2, and we must equate this to 0. So we'll have 6x equals to 2, divide both sides by 6. So the x value will be 1 over 3. And of course, to get the y value, we must substitute that x value into the original f of x. Okay. So let's do that. So I want to substitute a third. Okay, and we get 250 over 27. So that means our point of inflection, the coordinate will be x is a third and y is 250 over 27. That will be our point of inflection.